Hello AP Calc folks, this is Mr. McAllen, and what I plan to do today is go over a problem that will help us review how to find trapped areas, how to find volumes revolved around the x and y axis, how to find a volume revolved around an off-axis axis, I guess I'd say, like y equals -2 as in part E, and then come back and reconsider how to find a area of constant cross-section like in problem F. So the first thing we need to do before we can begin anything at all is we first have to understand the trapped area that we're dealing with. So I'm going to draw the picture, and we did this in class. So this is what we did in period 4, and later on period 8 we missed today because of an assembly, so I'm hoping that this is insightful and helps you with the homework you have this weekend. So we draw x squared plus 2, which is up 2 units. So it's a parabola. And everybody who's taken pre-calc should be able to draw the basic parent functions. So then we have, this is f of x. So then we graph the function g of x, and that's going to be 4 minus x. So it's going to be a function that looks like such. And this region here is region R. What I'd like you to notice is that region R is actually, it's the part trapped in the first quadrant. It's this region here, and I'm going to erase that just so that we can focus on that region better. So I'll just erase that area in between. I'll put an R back there again. And in the first part, we want to find the trapped area between the two curves. So we need to figure out what the limits are. And we know we start at 1, but we have to find out this limit a. Well, we have a function that's x squared plus 2, and the other function is y equals 4 minus x. So when we set those limits equal to each other, we get x squared minus plus 2 is equal to 4 minus x, and as a result, when we bring everything over to one side, and we factor, we have two intersections. The one intersection is at x equals -2 and x equals 1. Well, a would have to be 1 for this case, and that would make its corresponding y value to be 3. This point of intersection would be 1, 3. So now let's set up the integral, and I'm going to just erase this work. And let's set up the integral to solve the first part. And it's the integral from 0 to 1 of x squared plus 2 minus, oops, I made a mistake, I have my integrals in the wrong order. Remember, the strip of area, it's always top minus bottom, so it'll be 4 minus x squared minus 2 plus 2 dx. Now I'm going to pause the video, and then it's going to unpause real quick, but right now is a good time to pause the video and to try this out on your own and see if you can match up with my work. When I unpause the video, you will see the solution to it, so make sure you look through all the steps that I did to match them up with your own. Okay, so you should see this, the steps ahead here. I simplified the integrand, and then I had to differentiate it. And now I need to plug in 1, and so I'll plug 1 in for x, and I'll subtract that by everything with a 0 plugged in, and that's just going to be 0 for this case. So we end up having 2 minus 1 half minus 1/3, which will end up being 1 and 1/6 when you do all the fractions. So that's for part B. Now let's consider the integral setup for part C. It says to take that section, region R, and revolve it around the x-axis. So consider that you have this section of area, and you're going to, when you revolve it around the x-axis, it's going to be a washer. And the cross section of the washer is the patch of area that I have highlight or marked up inside region R. And when we revolve that, we have a formulation where it's going to be pi r outer squared minus pi r inner squared times the dx thickness. So now's a good time to pause that video and try it out on your own and see if you can match up with what I get when you come back from the pause. Do you match? Well, the outer radius is to the function 4 minus x, so that would be this dimension, and the inner radius would be to the lower function, which is x squared plus 2. So as you can see here, this is the radius outer and this is the radius inner. So now what I'd like you to do is pause the video, work through on your own of doing the simplification of the integral, and then evaluate it from 1 to 0, and let's see if you match up with that. The key words here is when you simplify this, you've got to remember to FOIL, and that means that when you multiply 4 minus x by 4 minus x, do not forget about the outer and the inner terms. Most people will just say that that's 16 minus x squared, but remember there's going to be a middle term composed of the outer and the inner. So give that a shot. Okay, well, we're back, and hopefully you can see that we have foiled and foiled again, and we factored out the pi, distributed the negative to this second set of terms, collected like terms, anti-differentiated, and our final answer after we plug in 1 is going to be 6.8 pi. So now let's take a look at what the next part of the problem is. I'm going to just clean up the slate here, and we're going to regroup and work on the last two parts. Now we consider part D. Part D says find the volume if you revolve the region about the y-axis. So when you revolve around the y-axis, you've got to look at the region and see that it separates at 1 comma 3. It separates at 3, so the integral will actually start at let me redraw that line. It would actually start at 2 and it would go up through 4, but the integral would change over at the value 3. So we have two integrals to write, and the two integrals will be for the, well, I'll just draw the section. This is at 3, this is at 2, this is at 4, and the top section is going to consist of using the function 4 minus x, and the bottom function is going to consist of using the function x squared plus 2. So I'm going to construct my two integrals. It's going to be from 2 to 3 using pi times the radius outer squared dy this time, plus from 3 to 4 pi radius inner. Oops, they're both outer radiuses, they don't have a disk. So pi r outer squared dy for the top function. So remember that you have to write these functions as x is a function of y. So in this case, x would equal 4 minus y when you solve for x, and in this case x would equal the square root of y minus 2. We would plug that in our integral. So for the first function, it's going to be from 2 to 3 pi times root y minus 2. And for the second one, remember to square that. And for the second one, it's going to be pi. The radius outer would be 4 minus x, 4 minus y dy. Remember to square that. I want you to anti-differentiate, and let's see if our answers match. Okay, we're back, and I want to just share with you the mess that we've created here. But just don't fret too much about it, because when we squared our when we did our squaring here, the square root disappeared, and we had to FOIL this out. So hopefully you agree with the foiling. Then what happens is we anti-differentiated, so hopefully you match up with the anti-differentiation for both. And then what we're doing now is, as I switch back to another color ink, I'll go with green. When you plug 3 into this integrand, the antiderivative, and then 2 in, you get those two components. And when you plug 4 in and 3 in, you get those two components. So now I'm going to pause and I'm going to work out the rest of the arithmetic. But I'd like you to pause too and try to work out the rest of the arithmetic on your own, just so you can go through the experience. Okay, well, we're back, and quite a mess again, and I noticed that I made a little bit of a mistake, so I just want to redeem myself. I didn't FOIL this properly, that term, and maybe some of you already picked up on that, but I fixed the foiling, and the final answer after all this work, if you can follow it through, is 5/6 pi for the volume. So let's take a look if we can find the original problem somewhere over here to the left and up. It now says to revolve this section around the line y equals -2. So let's try to do that, but I'm going to pause it and redraw everything down below, and we'll come back in a second. Okay, and really to make this quick, we have the case where we're now revolving this around the line y equals -2. This is 4 minus x, and this is x squared plus 2. And now remember, it's the same integration formulation. We're going from 0 to 1. We have dx strips, and we are going to do pi r outer squared minus pi r inner squared. And notice I'm factoring the pi's out, and my function for the outermost is going to be 4 minus x minus -2. And then because of this additional 2 units. And then the other one will be x squared plus 2 minus -2. Now the reason why we're subtracting is whenever we want to find distance between two objects, we always subtract their locations. So we have that's why we're doing that subtraction. And now I'm going to pause it, and I want you to simplify, FOIL, and integrate, and let's see if you can get the answer correct. And we're back, and hopefully you worked out all the details, and pretty complicated problem, no doubt. So we have taken care of the squaring, so double check that answer. We are distributing the negative. We are now grouping like terms. We finally anti-differentiate. You have to be really careful and take your time through this, don't be rushing. And then we plug in the upper limit, and if you look, the lower limit is 0, so we're not going to have any component from that. And we are just now trying to add fractions. And if you're careful, and I verified this with the calculator as well, in terms of what you would do with it if you got had a calculator on this part. And that's the correct answer. So hopefully this video has helped you. And I look forward to hearing your comments on this. I know it's 15 minutes long, but this should be something that you can always look back at and reflect on and see just how to work with the strategies. So I look forward to hearing your comments again, and we'll talk to you soon.